Your automatic transmission was engineered to last 300,000 miles. Not with pampering, not with premium fluid, not with dealer maintenance, just with basic mechanical respect. And yet, most automatics on the road today don't survive to 200,000. Many don't make it to 150. The engineering spec on paper and the field survival rate on the road don't come close to matching. And the auto shop industry has zero incentive to close that gap. The gap is you. Or more accurately, the gap is a handful of specific habits most drivers pick up in the first year of owning an automatic and never lose. 8 of them. Not one is exotic. Not one is expensive to fix. I've watched every one of these produce a rebuild bill in my own shop, some of them multiple times a year. And every single time, the driver had no idea they were doing anything wrong.
What is this?
Because nobody sat them down and explained what that specific button push was actually doing to the parts inside their transmission. Stay with me. If you're new here, hit subscribe and give this video a like right now. This is the channel where mechanics stop playing nice and start telling you what the shop industry counts on you never figuring out. Automatic transmission care is where the shop revenue model lives. A rebuild runs $2,800 to $4,800 depending on platform. That's the ATRA 2024 shop average. The fluid change and habit fix that prevents most of them costs $80. The math tells you which one the shop industry hopes you keep needing. 26 minutes, your transmission's next 100,000 miles. Fair trade. Here's what we're doing. 8 habits, counted down from least destructive to most. And I want you to promise yourself something before we get into number 1. It is not which fluid brand you're using. It is not how often you flush. It is not how hard you drive on the highway. It is a specific, single-second action that you have probably performed today, this morning, on the way to wherever you were going. And it takes $10,000 off the resale value of your car every time you do it. Let's start with a 30-second mechanics primer, because once you see what the fluid is actually doing inside the transmission, all 8 of these habits stop being arbitrary rules and start being obvious. Automatic transmission fluid, ATF, does 4 jobs at once. It's a hydraulic medium that transmits force from the engine through the torque converter and the clutch packs. It's a coolant that pulls heat out of the friction surfaces every shift. It's a lubricant for gears and bearings. And it's a cleaner that carries wear particles to the filter. Any one of those jobs failing produces a specific failure mode. All 4 fail at once, and you're looking at a full rebuild.
That's what caused the housing to crack.
The whole system runs on pressure. A pump inside the transmission pulls fluid from the pan and pressurizes it to somewhere between 50 and 250 psi, depending on the operating condition. That pressure gets routed through the valve body, a maze of channels and solenoids, to the specific clutch pack that needs to engage for the gear the ECM is commanding. Every shift is a controlled pressure event. Every habit on this list either interrupts that pressure, contaminates the fluid, or forces the mechanical parts to move in a direction the pressure wasn't ready for. That's it. Hold that in your head. Now, the 8 habits. Habit number 8. Hard acceleration on a cold transmission. I did this for years before I knew any better. 2018 Silverado. 165,000 miles on it now. But back at 40,000, I was pulling out of my driveway at 6:30 in the morning and stepping into the throttle to make the highway ramp on cold ATF. Never thought about what was happening in the pan. You leave for work in the morning. Engine's been off overnight. You start it, throw it in reverse, back out of the driveway. Throw it in drive, and step into the throttle to make the light at the end of the block. Cold ATF is roughly 3 times as viscous as warm ATF. That means for the first 5 minutes of driving, your transmission pump is delivering lower line pressure than the clutch packs were engineered for. Under gentle throttle from cold, that's fine. The friction demand is low. Under aggressive acceleration, the clutches slip a bit more than they should before locking, and every slip is friction lining wear. Cost of the habit? Nothing. Cost of the fix? Nothing. Warm the fluid the way the engineers designed it, by driving gently for the first 5 kilometers. That's it. No idling in the driveway for 5 minutes. That only warms the engine. The transmission warms up under load, gently, driving. Fluid at temperature by the time you're on the highway. Here is the extension. The same principle applies to your differential and your transfer case on any all-wheel drive vehicle. Aggressive acceleration on a cold drivetrain wears every gear oil lubricated component simultaneously. One gentle 5-kilometer warm-up protects 3 systems, not just the transmission. Now, habit 7 is the one drivers do specifically because they think it's helping them save money. And it's costing them a torque converter. Habit number 7. Coasting down long hills in neutral. The thinking here is straightforward. You're descending a long grade. You're going to burn no fuel if you're not accelerating. So you throw it in neutral, disconnect the drivetrain from the engine, and coast. The mileage gauge shows 1/10 of a gallon saved. You feel clever. Here's what actually happened inside the transmission. In neutral, the pump is spinning, but the drive gears are disengaged. Line pressure drops sharply because the ECM isn't commanding a specific gear engagement. Internal components that are still spinning, input shaft, pump gears, front planetary, set on most designs, are running on residual splash lubrication instead of pressurized flow. On a 15-minute descent down a mountain grade, that residual coating burns off, and you now have metal-on-metal contact at rotating speeds. Meanwhile, your fluid runs hotter than it should because the transmission cooler in the radiator only sees fluid the pump is actively pushing through it. And the pump isn't pushing much in neutral. The alternative is nothing. Leave it in drive. On any modern automatic, anything built after 2000 or so, the ECM cuts fuel injection automatically the moment you take your foot off the accelerator with the car in gear. Zero fuel, full engine braking, full transmission cooling. Same coast without the damage. What I keep coming back to on this one is that your fuel savings from coasting in neutral is a myth that predates fuel injection by 20 years, and it's still in circulation on driving forums today because nobody who repeats it has actually looked at what a modern ECM does when you lift off. Here is what nobody in the shop industry mentions when they replace your torque converter at 90,000 miles. This specific habit, done daily on a highway commute with a mountain grade in the middle, is one of the top 3 causes of premature converter failure I see in the shop. A converter replacement runs $900 to $1,800 depending on the vehicle. The habit that prevents it costs $0. The next habit takes the same misunderstanding of transmission physics and makes it 4 times worse in half the time. Habit number 6, brake torque launching. If you've never heard the term, but you've done it, here's the pattern. You're at a stoplight, foot on the brake, and you want the car to leap when the light turns green. You press the gas with your right foot while your left foot is still on the brake. Engine revs, torque converter loads. You release the brake and the car launches. Feels like you own a sports car. Here's what happened to the transmission in the 2 seconds you did that. The torque converter is a fluid coupling. Engine turns the impeller. Impeller pushes fluid at the turbine. Turbine drives the transmission. When you rev the engine against locked wheels, the impeller spins at high RPM while the turbine cannot move. The fluid gets whipped between them, and the mechanical energy of the engine converts to heat instantaneously. Fluid temperatures inside a stalled torque converter climb to 250 degrees Fahrenheit in 3 seconds. ATF starts breaking down chemically at 260. You have about 2 seconds of margin before you're cooking the fluid that was supposed to lubricate the next 100,000 miles. Cost of the launch? 2 seconds of fluid degradation per event, compounding across every time you do it. Cost of the fix? Nothing. 2-foot driving is a habit that persists from stick shift driving, where left-foot braking was legitimate. On an automatic, 1 foot on one pedal. Release the brake. Let the car creep, then accelerate. One thing that catches people. This same fluid shear heating happens on a smaller scale every time you shift from drive to reverse while the car is still moving. That's habit number 1, and the math on it is worse than what you just heard. Save the number 260 in your head. The next habit is where drivers destroy their transmissions without ever touching the shifter. Habit number 5. Driving on a low ATF level. This one is almost never intentional. Nobody purposely runs their transmission low on fluid. It happens because most drivers have never checked their ATF level, and most modern shops don't check it during an oil change. And ATF loss over time is real. Even without a visible leak, transmissions can lose several ounces per year through the vent, through seal weeping too minor to spot, through evaporation of the volatile additive package. Here's what happens when the fluid level drops half a quart below the full mark. The pump can still fluid couple in most conditions, but under sharp turns or hill climbs with a pan tilts and the fluid sloshes, the pump inlet starves for a fraction of a second. That cavitation lets air into the fluid stream and drops line pressure. Clutches that were supposed to engage under full pressure engage under partial. They slip, they heat, they degrade the fluid faster. Feedback loop that ends in a rebuild. The check takes 5 minutes and a shop rag. Most vehicles built before about 2018 have a transmission dipstick, usually red or orange handle near the back of the engine bay. Warm the car up, put it in park on level ground, pull the dipstick, wipe it, reinsert, pull it again, read the level. Bright red or pink and at full, you're fine. Dark brown or burnt smell, service. A 1/4 inch low, add half a quart of the manufacturer specified fluid. Dexron VI for GM, Mercon LV for Ford, ATF +4 for Stellantis, WS or T4 for Toyota, matched to your platform. Here's what nobody at the counter tells you. On many modern vehicles, Chrysler 9-speeds, ZF 8-speeds, most CVTs, the manufacturer removed the dipstick. Fluid is checked only from underneath through a fill plug at a specific temperature. If your vehicle is one of these, the check is a shop visit. The check itself should cost $30 max. If any shop quotes you $200 to inspect transmission fluid, walk out. The next habit is the one that shows up on a tow truck. Habit number 4. Being towed with the drive wheels rolling on the road. This one traps people because it happens exactly once, the day their car breaks down, and by the time they know it happened, they can't undo it. If your car quits and someone tows it away, and the drive wheels are still on the pavement turning, You have a problem developing right there on the strap. Front-wheel drive being towed forward on all four wheels. The drive wheels turn the transaxle, which turns the input side of the transmission, which wants to be lubricated by its pump. Engine isn't running, so the pump isn't running, so the internal moving parts are running dry. Every mile of that tow is metal on metal wear on parts you'll never see fail until they do. Rear-wheel drive being towed backward. Same problem, same failure mode, opposite end. The fix is simple and free if you know it before the tow truck arrives. Insist on a flatbed. All four wheels off the road. Cost is basically identical to a wheel lift tow in most states. If the tow company only has a wheel lift, use it correctly. Front-wheel drive car, front wheels up. Rear-wheel drive, rear wheels up. Four-wheel drive with an active transfer case, flatbed only, no exceptions. I've had 2 customers in the last 5 years learn this rule the day after their car was towed the wrong way. Both times the transmission that was working fine when they broke down needed a rebuild by the time it reached my lift. Here is the extension nobody in the towing conversation mentions. The same rule applies to any scenario where your car is being pulled behind another vehicle. RV owners flat towing their car behind a motorhome. Same rule. Autocross drivers trailering their track car home. Same rule. A 20-mile drag with rotating drive wheels on a dead transmission does more damage than 5 years of daily driving. The next habit is where the ECM stops trying to save you from yourself. Habit number 3, slamming manual downshifts at highway speed. A lot of modern automatics have a manual gate, plus and minus on the shifter, paddles behind the wheel, an M position on the selector. Drivers who like to feel involved use them. That's fine. The specific misuse is this. You're at 70 in 8th gear, and you drop 3 gears at once to overtake. You feel the engine wake up, you pull past, you feel like you got somewhere. Here's what happened. The ECM took the request seriously and commanded the drop. Engine RPM climbed from 2,500 to 7,500 in a second. The clutch packs for the lower gear engaged against the momentum of the vehicle, absorbing the difference between actual output shaft speed and the new gear ratio. On modern 8 and 10-speed automatics, this puts specific clutch packs under load they were engineered to see maybe 100 times over the transmission's design life. Do it once a week for a year, and you've consumed a transmission lifetime of load in 12 months. Cost of the fix? Nothing. Drop 1 gear at a time. Let the car settle in the new gear for a beat. Then, if you need more, drop another. If you have paddle shifters and you need actual engine for a highway pass, the correct sequence is 1 downshift, throttle input, and 1 upshift after the pass, not a 3-gear plunge. Here's what nobody in shop upsell mentions. The wear from aggressive manual downshifts is undetectable on a standard diagnostic scan for years because the shift adaptive tables quietly compensate for the increased clutch friction until the compensation runs out. When it does, the failure looks like sudden gear slip out of nowhere, and the rebuild bill lands cold. If you're past 100,000 miles with a manual downshift habit, book a transmission service before the compensation runs out. The next habit is where drivers break their own cars trying to force something that has an easy fix. Habit number 2, forcing a stuck shift lever. You put the car in park, get out, come back a while later, get in, put your foot on the brake, try to shift out of park, and the lever won't move. You try harder, you wiggle, you yank. You end up jamming a screwdriver in the console to force it out. Here's what was actually happening. Modern shift levers have a mechanical interlock that requires the brake pedal to be depressed before the lever can leave park. The interlock is powered by a solenoid, and the solenoid is on the same fuse as the brake lights. If a brake light bulb burns out or the fuse blows, the solenoid doesn't engage and the shifter locks in park. There's a manual override on every automatic vehicle built in the last 30 years for exactly this situation. The shift lock release, a small hole or button next to the shifter, usually covered by a removable plastic cap. Press it while pressing the brake and the shifter frees. Cost of the correct fix: 5 seconds and a glance at the owner's manual to find where the release is on your specific vehicle. Cost of forcing the shifter: usually a broken shift cable, sometimes a damaged park pawl if you also manage to punch through the interlock physically. Shift cable replacement runs $150 to $400. Park pawl damage is transmission removal. Call it $1,000 plus. I've replaced 2 shift cables this year on customers who called me after the fact. One on a 2015 Camry, one on a 2017 Odyssey, both because a brake bulb was out and they didn't know about the interlock release. Here is the extension. This same brake light fuse control's interlock circuit is why a burnt-out brake light frequently causes drivers to get stuck in park at parking lots and gas stations. Check your brake lights once a month. 15 seconds. Have someone stand behind, press the brake, verify all 3 lights come on. Prevents the panic that leads to shifter forcing. And now, number 1. The habit that kills automatic transmissions faster than any of the 7 above, and the one I promised you at the start was not what you think. Habit number 1. Shifting from drive to reverse or reverse to drive before the car is fully, completely, absolutely stopped. This is the killer. And I told you it was not what fluid brand you use. It's not. It's not how often you flush. It's not how hard you drive on the highway. It's the parking lot habit millions of drivers have. You're pulling into a parking spot. You almost reach the curb. You throw the shifter to reverse before the car is finished creeping forward because you want to back out in one motion. Or the reverse, you're backed into a driveway. You shift into drive while the car still has a hair of backward momentum, so you can pull forward smoothly. Here's what those specific moments do to the transmission. When you shift from drive to reverse, the ECM commands one set of clutch packs to disengage and another set, the reverse clutches, to engage. If the input shaft is still spinning in the forward direction because the vehicle is still moving forward, the reverse clutches engage against a spinning shaft. The energy of the still moving vehicle has to be absorbed by those clutch packs in a fraction of a second. The clutches were designed to engage from a stopped condition and slowly build friction as pressure builds, not to slam against a spinning input shaft carrying the momentum of 2 tons of car. Do this once, you don't hear anything, you don't feel much, and the transmission survives. Because the clutch packs have engineered surface area to absorb a limited number of these events. Do it 3 times a day, every day, for 2 years, and you have consumed that engineered surface area at 8 or 10 times the design rate. When the clutch packs reach the wear limit, the transmission starts slipping in reverse, or in a specific forward gear. The diagnosis is worn friction elements. The fix is a rebuild. $2,800 to $4,800. Cost of not doing it: 1 second of your day per parking maneuver. Foot on the brake. Complete stop. You should feel the car settle into full standstill. Only then shift. That's it. 1 second. Here is what I watched last spring on a customer's 2016 Ford Escape. The 6 F35 6-speed automatic. A workhorse platform that should hit 250,000 miles if you treat it right. His had failed at 88,000. Fluid was still pink and clean. Maintenance record was spotless. 3 fluid services on schedule, all documented. Same platform runs to $250,000 on other cars I've serviced. What did his transmission do that theirs didn't? He was driving rideshare full-time, 30 pickups and drop-offs a day at curbside, 4 years of it. Every single one of those was a D to R shift, or R to D shift, and about half of them happened while the car was still creeping. 60 partial motion shifts a day. Do the math over 4 years. That transmission consumed a lifetime of engineered clutch surface in a third of its design mileage. Same fluid brand, same schedule, same everything, except that one habit. That's the killer. 1 second, complete stop, then shift. The bonus habit that finishes the job. Never shift to park while the car is still moving, even at a walking pace. Park engages the mechanical park pawl, a small hardened steel finger, into a part gear at the output shaft. If the vehicle is still moving, the pawl gets slammed into a rotating gear tooth instead of resting into place. On some transmissions, the pawl breaks. On others, the gear tooth breaks. Either way, you now have a rolling car that can't be locked, and the fix is transmission removal. The full sequence: brake, complete stop, brake still held, into park, brake released. 3 action items you take from this video. 1. On your next drive, notice how many times you shift from drive to reverse or reverse to drive without a complete stop. Count them. Most drivers count higher than they expected. I did. I counted mine after a customer's transmission on a 2017 Altima came apart at 88,000 miles. And I realized I was doing the same thing 3 or 4 times every trip to my own shop. My Silverado is at 165 now on the original transmission, and the fluid still comes out red. Not because I got lucky, because I stopped doing at 40,000 what most drivers never stop doing. 2. Check your transmission fluid level this week. If your car has a dipstick, that's 5 minutes and a shop rag. If it doesn't, book a fluid check. Should cost $30 max. If the fluid is dark or smells burnt, that's a service call. If it's low, that's a service call. The whole audit takes an afternoon, not a Saturday. 3. Save this list somewhere. Not to memorize, just to reference next time somebody in your family is about to shift from drive to reverse with the car still creeping. 1 conversation, 6 seconds of habit change, and their transmission lasts to 300,000 instead of 140. Here's the math the shop industry doesn't publish on its website. 300,000 miles is what your transmission was engineered for. 200,000 is what the average one on the road survives to. Sometimes not even that. The gap is those 8 habits, and mostly the one at number 1. You just heard all of them. What you do at the next parking spot is up to you. If any of this saved you a diagnostic visit or a rebuild bill, hit subscribe. If you know somebody who's about to buy their first automatic and doesn't know these rules, send them the video. Next up on this channel is why some automatics hit 300,000 miles on the original transmission, and others die at 120 on the same platform, same fluid, same climate. That answer will surprise you. See you